National 5 Maths, Practice Paper H, Paper 2. Now in the first question we've got to find out the value of an antique chair after 3 years. So it starts off being £600, it's an increase of 4.5% per year, so 3 years. So it's going to be 600 multiplied by, now 100 plus 4.5%, so 100 plus 4.5 is 104.5%. So we can divide that by 100 so we can get a decimal we can actually work with here. So it's multiplying by 1.045. It's over 3 years, so we're going to do that to the power of 3. So if you multiply these things together, you get 684.699, etc. Now we need to round that to 2 decimal places because it's money, so we need to go to the nearest penny, unless it tells us otherwise in the question, but it doesn't here. So it's going to be £684, and that's going to be, the 9's going to round it up to 10, so that'll be 0 and that'll be 7. So it'll be and 70 pence. Now it's always a good idea to, with this type of question, is just to double check to see if it asks you how much has gone up in value or what the new value is. Here it's just asking you what it's worth in 3 years, so you don't need to do anything extra there. Now in question 2, we've got to find out a standard deviation for this set of data. So to work out the standard deviation, we need to add them all together and then divide by 7 because we've got 7 items of data there. So x bar equals the total is 49 divided by 7, and that is 7. We then fill in our table. So the first column is x. So you write down all the items of data in the column. So 13, 7, 0, etc. Then you do x minus x bar. Now that's where you subtract the mean from each of these items of data. So we subtract 7 from each of these numbers. And that gives us the following. You then have to square each of these numbers. There shouldn't be any negatives in this last column because when you square all these, you're going to get all positive numbers. You then got to add that column up because we want the sum of x minus x bar all squared, and that's just that last column added up. So using the standard deviation formula, it's the sum of x minus x bar all squared, which is 94, divided by n minus 1. N, there's 7 items of data there. Subtract 1 is 6. You've got to square root all of that. And that comes to 3.95811, etc. And we're just going to round that to 3.96 as our standard deviation. Now in the next part, we're told that the following season the team appoints a new coach. A similar series of matches produces a mean of 27 and a standard deviation of 3.25. So we can write down a table for the old coach and for the new coach. We can compare the mean values and we can compare the standard deviations. So the mean values, we've got 7 with the old coach and the mean is now 27, so it's gone up quite a lot. The standard deviation is what we've worked out as 3.96, and then it's now 3.25. So we're going to make 2 comments, one about the mean values and one about standard deviations. Well, I've got that written down here already, prepared. So my 2 statements, first one, under the new coach, the mean number of points increases from 7 to 27 points, and the standard deviation decreases, so the number of points scored is slightly more consistent. So a comment for mean and a comment for standard deviation is what you need to do here.